Next up, we have Michael Sinatra from Berkeley with IPv6 versus IPv4 NAT. Why not both?
Okay, so why are we interested in doing this? And I'll explain a little bit what the this is in just a minute. But when I started to implement IPv6 on my network in a more production fashion and in a more comprehensive rollout than the sort of experimental fashion that we had, I was interested in finding ways to dramatically reduce our consumption, at least our consumption rate of IPv4 addresses, if not turning off IPv4. So of course I naturally became attracted to NATPT, and then we had RFC 4966 and the big debate about whether NATPT was right or wrong, whether it should be historical or whether it should be continued development. But the biggest showstopper for me was that for applications which don't understand IPv6, which won't work without an IPv4 stack on a host, NATPT won't help you, at least not yet. There are some proposals to change that, but that is not quite yet in the NATPT realm, as many of you probably found out when we were using NATPT last hour. So I wanted something that I could do right now and start testing right now and start coming up with some results and figuring out what I could do. And of course, I want to keep the end-to-end principle, particularly with IPv6. I'm willing to make a pact with the devil when it comes to using IPv4 NAT as long as I have a backup mechanism for having IPv6 end-to-end connectivity. So if you want end-to-end connectivity, use IPv6. So the idea here is of relatively simple design, just as the proof of concept, where we have, I wanted to keep the NAT, by the way, as far away from the end-to-end v6 portion. I wanted to keep all that muck out of the way as much as I could. So what we have here is a NAT box that is a one-arm NAT box. This router is a standard dual stack router that has v4, v6 on it in globally routable address spaces. And then I have a single interface that has a globally routable v4 address and a globally routable v6, globally routable globally routable v4 address and an RFC 1918 v4 address, and no v6 on it. You can actually disable v6 if you'd like. And then each client now is configured however you like, using stateless autoconfig in DHCP v4 or DHCP v4 and v6 or whatever you want to do, to have globally routable v6 and IPv4 NAT. It's very simple. This is all stuff that we all do. And what it does is you point the default route over to the NAT box here. A packet goes in the NAT box, it gets translated and goes back out through the router. That's for v4. For v6, you just go straight through. So this is a very simple solution that you can do right now that will reduce your IPv4 address consumption and also allow you to use v6. Now, in terms of the NAT box, having a NAT box on every little client network is maybe not very scalable. So there are other ways you can implement that. And one possibility is if you have a layer 2 distribution layer, you can plug that NAT box into that layer 2 into the layer 2 switches, the aggregation switches that you have, and tag VLANs over them. Now there's some obvious security issues with that. You're going to have all kinds of customer traffic going through that one box. So you do have to be a little careful with that. You could also put this NAT box up in your core and use some sort of MPLS magic or whatever you want to do to send all the RFC 1918 traffic to it and go ahead and translate it. In addition, routers should be able to do this. And I'm in the process of testing that with a few different routers. You should be able to configure this stuff right on the router if you want. It's a little bit tricky, it has turned out. That's actually, somewhat not very easy to do. So, this is basically kindergarten technology. There's nothing really new here. It's something you can implement right now. And I'm just trying to sort of get some ideas for people to start talking about how they might use translation technologies, both NATPT and also some of these other things, in order to try to reduce that v4 footprint but still provide good v6 services. So I won't really read the advantages. The disadvantages of this, particularly with respect to NATPT, is you still have to have dual stack clients. I don't think that's a big disadvantage because clients know how to do dual stack. We have a lot of operating systems that have been configured and programmed to do dual stack for a long time. It's well supported, it's well known. So that's not a big deal. I talked a little bit about the issue of scalability in the last slide, but there's also the notion of capacity planning. You've got all your stuff going through this NAT infrastructure. Now, most of the talk among the ISP community is you're going to have to do this anyway at some point to reduce the IPv4 address footprint of some of these larger ISPs. So in a lot of service providers and in universities as well, this is something we're going to have to deal with anyway, is the performance of either NATPT or IPv4 NAT in combination with IPv6. But you can engineer your way around this, and you can actually use it as an incentive to get people to migrate to IPv6, just as long as you don't give them too much incentive to, say, migrate away from you. But by giving them a slightly degraded IPv4 service, that might get them to move to IPv6 faster. And in certain particular scenarios where you have, and it depends on really how likely you think this scenario is going to be, but in a situation where you have applications that all support IPv6, but you've got some networks out there that you want to reach that still don't support IPv6, then certainly NATPT is going to be your friend in that situation. So that's actually one case where you'd want to use NATPT. With all the discussion that we have around what are we going to do when the free pool runs out, particularly in our own networks, how are we going to be able to support all of our customers with the address space that we have, given that we're still going to need to have some sort of v4 solution going on for a long time. I'd like to add this in because I think it does a really nice job of making sure that we provide end-to-end v6 services, which is sort of my philosophy. I mean, v6 is there to provide address space relief for us, but it's also there to provide end-to-end transparency for our customers. So that's why I kind of like this model, and NATPT does that as well. And if NATPT can start supporting legacy applications, then we'll have two good models to use in order to deal with translation. If we think this is useful, I'm happy to post this to the various wikis that deal with IPv6, like the Aaron wiki and Randy's wiki that we have, and go through and talk about how I got beyond the proof of concept network, which, by the way, is running. It actually is in my office and a few other locations where we have just, IT staff working. So we know that it's working in this case. But what happens when we roll out in larger production, and what kinds of results do we get, which, of course, is beyond the scope of a lightning talk. But I'm certainly happy to contribute to this as another model, another thing that we can do for translation. So that's really all I have. Thanks.
Any questions? I have a question for you. Are you willing to try this out at the next NANOG for the next IPv6 summit?
I would be. I do think it was a lot more fun to try out NATPT and to really see where we got with that, because that's something that I think a lot of us haven't had a lot of experience with. But I don't know if I'll be available for the next NANOG, but certainly the October one in Los Angeles I should be available for. So if we're interested in playing around with it, we can do that.